Hi there, welcome to our virtual open day here at UCLan and to this subject-specific introduction to software engineering. My name's Dr. Nick Mitchell and I'm the course leader for the Software Engineering Bachelor of Science with Honours degree. I'm guessing that there are two main questions that most people have on their minds at this time, and that's firstly, why would I want to do a software engineering degree? And secondly, why would I want to do that at UCLan? Over the next few minutes, I'll try to help you answer those questions, but if there's anything else specific that you'd like to know, do please join us at our live chat Q&A session later on, or after the event, feel free to drop me an email. As a student of software engineering, you'll be learning what goes into the development of large and small software systems that work efficiently and are effective at solving problems. Of course, the ultimate expression of that software is the code or the computer program itself, and so naturally, programming forms an important part of the course. There's an awful lot more to software engineering than just programming, however, but before I move on to talk about that, I just want to reassure you that there's absolutely no requirement for you to be already able to program before you join the course. We'll teach you everything you need to know from the ground up. Having said that, it would be a good idea if you knew that you liked programming before embarking on a degree in software engineering, because you will be doing so much of it. If you've never tried programming before, then I'd strongly recommend you follow one of the many millions of tutorials that are on the internet and just have a go and see what you think. The language doesn't matter, because the logic and the thought process are the same from one language to another. In the first year of the course at UCLan, we'll introduce you to C++, but you'll also use C#, Java, and other languages in later years. Now, a lot of people like to compare software engineering with civil engineering. That's the design and construction of things like roads, bridges, big buildings, and it's quite a useful analogy. But in the analogy, coding or programming is a bit like bricklaying or pouring concrete. If you wanted to build a road bridge over a river, you wouldn't just turn up with a cement mixer and start pouring concrete and chucking some bricks around. You'd first need to understand something of the traffic that the bridge was required to support, maybe about the ground on which it was going to stand, and how it was going to be connected to the surrounding road network so that vehicles could drive onto it safely. And from that understanding, you'd come up with a design, a set of blueprints, and build the bridge according to your design. Hopefully, as part of the design process, you would have done some calculations to give yourself confidence that the bridge would be robust, so that if there was a traffic jam, lots of heavy lorries parked on the bridge in a bad winter's storm, the bridge wouldn't fail and collapse into the river. If we try and apply these engineering ideas to software, you can see that before we start writing any code, we need to have a design and write our programs according to that design. The design needs to be based on a good understanding of what the software is required to do and the way in which it's going to be used, so that when it's put under stress, it isn't going to fail. So, on this course, you are going to learn how to analyse the requirements for software systems, design and implement solutions in an organised, well-structured manner so that you can have confidence that your solutions are actually going to work. And you'll be doing that from day one of the course. So this is a very practical course with a vocational focus. If you studied computer science at a more traditional university, you'd get a lot more in the way of theory, but at UCLan, our aim is to help you get a job in the software industry if that's what you want to do, and our graduates are very successful at doing just that. But this isn't just a training course. It's a degree, and the skills that you will master in order to be a successful software engineer can easily be transferred to other areas of employment. As well as your programming skills, you'll be able to think clearly and logically when analysing problems. You'll be able to communicate technical information, perhaps with non-technical people at the appropriate level. You'll be able to work effectively in a team of people from different disciplines. You'll be able to make arguments, you'll be articulate and numerate, and you'll have an appreciation of working within a legal and ethical framework and of what it means to work according to professional standards. And these are all very transferable skills. I want to talk for a little bit now about the structure of the course. And software engineering is one of a number of different degrees we offer in computing. And all those degrees share more or less the same modules in the first year. And there are a couple of reasons for that. We feel it's important that we give you a broad basis to your education in computing, and also that you get an appreciation of the other specialisms. In the workplace, you might find yourself having to work with someone who's a network engineer, or someone who's a database engineer, or someone who is a security expert. And having a basic knowledge of their subject as well as your own helps you to be able to communicate and work more effectively alongside them. But the major benefit of doing it this way is that at the end of the first year, because you've all studied the same broad basis, you have the opportunity to change between any of our computing degrees without penalty. No matter how much information we give you at this stage, we recognise that you're not really going to understand what the subject is like to do at university until you've started doing it. And so we've tried to design in this little bit of flexibility into the course in case when you turn up, the subject isn't quite what you expected it to be. And we do have people transferring both onto and off software engineering at the end of the first year every year. I mentioned earlier that you'd be designing software solutions from day one of the course, and for the first month you'll be working as part of a team to design and implement and test and use a mobile phone app. Of course, we'll take some shortcuts and you'll get an awful lot of help along the way, but it will give you an experience of doing an end-to-end software development project. After that project's over, you'll then go on to do 5 other modules in different topics in parallel for the rest of the year. And that project will give you a context in which you can understand how the different topics that you're studying individually fit together. But that's not the real reason why we give you this project to do at the beginning of the course. By doing one module intensively, you get to make some rapid progress and get a real sense of achievement and a sense of what computing at UCLan is all about. But also, you get to know us, the staff, pretty well, and you also get to know each other. It's very easy to become isolated when you move to university, especially if things aren't going so well. And what we try to do is help you to build a friendship network that will become a peer support network and get you through any difficult times that might come along. Speaking of supporting you, at UCLan we do have a great system of student support. Within the subject area, obviously you've got your subject tutors, but we also have a student coach who you can make one-to-one appointments with, and they can help you with study skills. We also have a peer-assisted study support scheme whereby second and third year students are available to facilitate discussions among small groups of first year students to help with their learning. They're not teaching you, this isn't instead of having classes with teachers, this is as well as that, and it's really successful because these guys have recently been through what you will be going through in the first year. They've done the same modules. They won't give you the answers, but they might be able to help you figure out the answers for yourself. Outside of the subject area, the university has a place called the I, that's I for information, and it's a one-stop shop that is your portal into all the student services that the university offers. So as well as being able to give you financial advice and accommodation advice, things with general day-to-day living, they're also a portal into mental health services and disability services, which are really, really good at UCLan. Having said that these services are really good, the onus is on you to engage with them if you need to access them, and I suppose this is one of the differences between school, college and university. Academic staff can refer you to wellbeing services for a number of reasons with your consent, but because you're part of such a large group of students, it's unlikely that academic staff will notice straight away if you have a problem. And this is where being part of that peer support network I mentioned earlier is so important, so that you can guide your friends to these services when they need them and they can guide you. So, Having successfully negotiated your way through the first year and into the second year, this is where you start to specialise, and you'll find that the modules get smaller numbers of students on them, and you're doing more things focused on software engineering. The first year will give you the basics in programming. You will then take that with you into the second year, having got a very good mark in the programming modules, and start learning advanced programming techniques. But alongside that, the other modules are going to tell you how to design those programs. So programming almost becomes the language that you're speaking to express the ideas that you're learning in the other modules. A bit like if you were learning about literature, you'd write essays in English. Here you're learning about software architecture, algorithm design, and you're expressing those ideas in a programming language. There's another team software development project towards the end of the second year, which is a good chance for you to put into practice all the things that you've learnt, not only in software development techniques, but also in team working and design. And we'll also do some career development work with you in the second year. This is important because in between the second and final year, everybody has the opportunity to do a sandwich placement, and I would heartily recommend this for all software engineers. Sandwich placement is a year spent in industry working for a real company doing a real software engineering job. You have to apply for these jobs yourself with an application form and go through the interview process as you would for any job. They are paid, and although they don't count towards your degree classification directly, most people who go and do these placements come back and do very much better in their final year. And the reason for this is that actually going out there and seeing software engineering for real gives you a context for understanding the things that we talk about in the final year. Although we do our very best to make things as realistic for you as possible, the projects that you'll work on within university are of necessity very much smaller than the ones that you will see in your year in industry, and there really is no substitute for experiencing that size of project for yourself. Of course, the other major benefit of doing a sandwich placement is that you get to put it on your CV. That's real-world software engineering experience as part of your university course. Some students even come back from their placement with job offers, and that's a real pressure off in the final year when you don't have to worry about finding a job. So into the final year, where as well as studying advanced topics in software engineering, you actually get an optional module. You can choose something that interests you to study. At the moment, we've got options available in computer networking, computer graphics, data science, and artificial intelligence. And also, you do your final year honours project. The final year project is a very important piece of work. It's worth a third of the marks in the final year and counts up to 2/5 of your degree classification. But it is your chance to put your personal stamp on your degree because you have a completely free choice as to what you do for that project. In the past couple of years, I've had a very diverse range of projects, from someone using artificial intelligence to try and analyse historic stock market data and make predictions about the future, to someone writing a Game Boy emulator, to using complex steganography algorithms to hide information within images and other files. You'll be allocated a supervisor who's a subject specialist, and you'll meet with them maybe individually or in small groups once every week or so, and they'll give you feedback and advice, but they won't tell you exactly what to do. The project is an independent piece of work, so you have to think of a problem that interests you, find for yourself an appropriate solution to that problem, and that will involve learning how to do things that we haven't taught you, and then using those things that you've learnt, produce a working solution. At the end of the project, you'll write a 50-page report about the whole process that you went through, and you'll demonstrate your working solution. And this sort of independent problem solving is the thing that employers are looking for graduates to be able to do. So Your project demonstration can form the centerpiece of your portfolio and discussion point when you go for interviews, when you're applying for jobs. I mentioned that you demonstrate your solution as part of your final assessment for your project, but in fact demonstrations form part of the assessment regime through all 3 years. I should probably expand a little bit on how we do assessments at UCLan. Because software engineering is a very practical subject, a lot of the assessments are practical. You do have exams. They start in the first year. They develop through the second year, get longer and more of them into the final year, where they count up to 50% of the individual modules. All of our modules have at least some element of coursework to them. In fact, some of the modules are 100% coursework, and that coursework is organised and assessed in different ways according to the needs of the specific subject. Some of them build up a portfolio of several smaller pieces of work over the course of the year, which add up to the final mark. Some of them have one big piece of work that you work on over a long period of time. As far as marking these things is concerned, sometimes you hand it in and there's written work to go with it. Sometimes you demonstrate it in front of a tutor, sitting in a lab side by side, one-to-one. Sometimes it's stand up and present. Sometimes it's a group presentation. It depends on the individual module, but there's quite a mixture of different ways of assessing people. And the feedback can also come in different ways. If it's a one-to-one demonstration, you might have a conversation where you're given verbal feedback in the moment, or it might be that you have to wait a week or two to get some written comments back on a piece of work that you uploaded. If you're worried about presentations, in that first project module that you do at the beginning of the first year, we try and build a safe space in smaller environments where you can take yourself gently out of your comfort zone and dip your toe in the water. If you're worried about exams, then the exams in the first year are generally focused more on multiple choice tests, short exams, where they give you a chance to get back into the swing of exams, especially if you haven't done any for a long time, and then they build up and get gradually more like traditional exams towards the final year. But as with all these things, the more you do them, the easier they become, and so practice is key to success in all these assessments. But of course, being at university is not all about exams and study. There are innumerable sports clubs and societies for you to get involved in that come under the umbrella of the Students' Union, but within computing itself, we have a very lively computer games society at the moment, and we have a BCS, that's a British Computer Society student chapter, and there's opportunities to organise trips and various activities on and off campus. Also, in recent years, a lot of software engineering students have got involved in competitions, like a defect finding competition that's organised by a local company. Not only is it a chance to take part with other students from other years and other universities, but it gets you out into industry and see some of the premises and the activities of commercial organisations. We're occasionally able to organise trips further afield. Last year, a colleague and myself took a group of students down to Bletchley to the National Museum of Computing. The year before that, another colleague and myself took a small group of software engineering students to Sri Lanka, where we have a partner college. And speaking of partner colleges, there are various places in the world where UCLan software engineering degrees are on offer. Sri Lanka is one, Cyprus is another, and you're able to spend one of your years in one of those places if you wish to. And if you're into languages and travel, you also have the opportunity to spend your second year at a university in one of many different countries studying an equivalent second year to the one that we do here at UCLan. Well, I've been talking for about 20 minutes now, so I guess it's about time to stop. Thank you for listening. As I said at the beginning, if there's anything else you'd like to know about the course, please do get in touch.